Hello everyone, I am Chavi and welcome to the playlist of data science. So we were solving questions in the last videos. So we will continue solving questions. I have another set of questions of my end semester examination. So let us solve. The first question is how unstructured data is transformed into a format suitable for machine learning models. So unstructured data such as text, images, videos must be converted into structured numerical format for machine learning. This step includes text cleaning, remove irrelevant characters, convert text to lowercase. Next is tokenization, split text into individual word or tokens. Next is stop word removal. Remove common words like the, is, etc., which do not add significant meaning. Tokenization, split text into individual words or token. Stop word removal, remove common words like the, is, etc., which do not add significant meaning. Lemmatization and stemming. Reduce words to their root forms like running to run. Feature extraction, use techniques like TF, IDF, word embeddings. Structured format represent data as numerical vectors or arrays for machine learning algorithms. Next is importance of legal classification in grievance redressal. So legal classification plays a crucial role in grievance redressal by first is streamlining processes. So automates categorization of complaints into appropriate legal categories. Example IPC sections. Second is improved accuracy. So reduces human error in classifying complaints. Third is faster resolution. Prioritizes and routes complaints to the correct department. Ensures fairness, provides inconsistent handling of grievances, enhances scalability, handles large volume of complaints efficiently. Next question is how TF and IDF or word embeddings can be used to extract feature for complaint text. Right. So first is TF and IDF. Purpose is to identify important words in the complaint by assigning weights based on their frequencies in the document and rarity across the corpus. Example, for the complaint theft of my mobile phone, TF-IDF highlights theft and mobile as the important terms. Second one is word embeddings. What is the purpose of word embeddings? Maps words into dense vectors capturing semantic relationships. For example, words like theft and robbery will have similar embeddings, allowing model to generalize better. Both the methods with TF and IDF and word embeddings help in transforming complaint text into a format suitable for machine learning classification. Right. So moving on to the next question. This was all about the first question. The next question is life cycle of a data science project. So we will know about the life cycle of a data science project. Okay. So first stage is define the problem. So in defining the problem, the objective is clearly understand and define the business problem or research objective. Right. Now key details and tasks. What is the key details and tasks? Problem statement, expected outcome and scope of the project. Next is tools and library. Tools and in the tool list and library, problem specific discussions. Right. The second stage is data collection. So gather data from relevant sources. And what is the key details? Collect structured, semi-structured or unstructured data. And tools and library used are SQL, API, web scraping, Pythons, etc. Now third stage is data exploration and preprocessing. Now analyze and clean data to make it usable for modeling, handling missing values, outlier detection and exploratory analysis. And the tools that are used is Python, Pandas, Seaborn and R. Now next is feature engineering. So what is the objective of feature engineering? Select or create features to improve model performance. Now next is feature selection, extraction, and transformation. And the tools used are Python, sklearn, feature tools. Right. So model selection, next stage is model selection and building. Choose and build machine learning models based on problem. Select algorithm, train models, and tune hyperparameters. The tools are used in sklearn, TensorFlow, and PyTorch. Right. Next stage is model evaluation. In model evaluation, the objective of model evaluation is assess the model's performance on unseen data. Use metrics like accuracy, precision, recall, and F1 square. Python, sklearn, and matplotlib. Next stage is model deployment. So deploy the model into production environment for real world use. The use of API, cloud services, or edge devices for deployment, and the tools used are Flask, Fast API, AWS, and Docker. Next is monitoring and maintenance. Monitor the deployed model's performance and update as necessary. Now, track, drift, retrain models, and handle feedback loops. Next is Prometheus, Grafana, and Python scripts are the tools. Next, communication and reporting. So share findings and insights with stakeholders, create visuals, dashboards, and reports. The tools used are Tableau, Power BI, Python, Matplotlib, Seaborn, etc. So this table covers the essential stages of the data science project lifecycle and can be adapted based on the specific nature of the project and its requirement. Let me know if you need further elaboration on any stage in the comment section, of course. So if you have any doubts, any queries, please do comment in the comment section. Hit the like button. Please do subscribe to my channel. So moving on to the next question. That is, explain the role of text mining in automating grievance redressal systems. List the key steps involved in pre-processing unstructured text data. Right. The role of text mining in automating grievance redressal systems. The text mining automates grievance redressal system by extracting meaningful information from unstructured text data. Here's how it contributes. So first is automated categorization. The text mining classifies complaints into predefined categories without manual intervention, helping route them to the right department quickly. Second is sentimental analysis. Identifies the tone of the complaint, enabling prioritization of urgent or high priority issues. Third is efficient query handling. Automatically identifies key information to resolve queries or trigger appropriate actions. Fourth is pattern recognition. Detects trends or recurring issues, helping to improve services or resolve frequent grievances. Improved accuracy. Reduces human error in interpreting or classifying complaints, ensuring consistent responses and efficient problem solving. Now, what are the key steps involved in pre-processing unstructured text data? Okay, so text cleaning as removing unnecessary characters, punctuation, and special symbols, and convert text to lowercase. Next is tokenization. Split text into individual words or tokens for further analysis. Removing stop words. Remove common words that don't contribute significant meaning. Next is stemming and lemmatization. Reduce words to their root form to normalize variations of the same word. Next is vectorization. Convert text into numerical format using methods like TF, IDF, or word embeddings to prepare data for machine learning models. These steps are essential for transforming raw, unstructured complaint data into clean, structured format suitable for automated processing, classification, and response generation. Thank you. So the next question is explain the key differences between k-means clustering and hierarchical clustering algorithms. What are the advantages of hierarchical clustering over k-means when visualizing cluster relationships? So the key differences between k-mean clustering and hierarchical clusterings are: first is clustering approach. So k-means have centroid based, means partitioning based k-means approach, and the approach that hierarchical clustering follow is agglomerative or divisive approach. Okay, bottom up or top bottom approach. Now k-means clustering, the number of clusters are predefined, but in hierarchical clustering no need to specify the number of clusters upfront. Now in k-means clustering works best with spherical clusters. The cluster shape should be spherical clusters, and in hierarchical clustering can handle arbitrary shaped clusters. Like hierarchical cluster can handle the complex shape as well. Now the output of k-mean clustering comes in flat partition or data into k clusters. Now the output comes in dendrogram, okay, showing cluster hierarchy. Now computational complexity depends on k and iteration, and for hierarchical it depends on more computationally expensive. Now initialization, sensitive to initial centroid selection and no initial selection required, right? And the next is handling outlier. In k-mean clustering, sensitive to outlier, but in hierarchical clustering more robust to outliers. Okay, so with scalability, k-means clustering is better for large data sets, but hierarchical clustering is not ideal for very large data sets. So next is cluster relationships. Does not provide information on clusters, shows relationships between clusters in the form of dendrogram. So that are some differences between k-mean clustering and hierarchical clustering. Next is advantages of hierarchical clustering over k-mean clustering when visualizing cluster relationships. So first one is dendrogram representation. Hierarchical clustering produces a dendrogram which visually shows the hierarchical structure of clusters. This allows you to understand how clusters relate to each other at different levels for granularity, which is not possible with k-means. Next is no need to predefine cluster. Unlike k-means, which requires the number of clusters k to be predefined, hierarchical clustering allows the user to decide the number of clusters at any level by cutting the dendrogram. Now better insight into cluster relationships. Hierarchical clustering gives a clearer view of how clusters are nested within each other, providing a deeper understanding of the similarities and differences between clusters. Next is flexibility with arbitrary cluster shapes. Hierarchical clustering can handle complex shape of clusters, unlike k-mean, which assumes clusters are spherical. The flexibility allows hierarchical clustering to represent real-world data more accurately. So in summary, hierarchical clustering excels in providing a visual intuitive representation of how clusters are related, which can be particularly useful in understanding the structure of the data. K-means, while efficient for large datasets, does not offer this level of insight into cluster relationship. So that's all for today. Thanks for watching.